start our lecture first. You know the third unit is organic chemistry. So from the beginning onwards I am saying if the first unit means inorganic chemistry, not only the partition chemistry, combined with the P-block element and a trends in periodic table, HSAP, acid base concept, so everything together, that's why we classify that as inorganic chemistry. Second unit, physical chemistry, not only the thermodynamics, that's why we consider physical chemistry, including electrochemistry and also corrosion also. Third unit, organic chemistry, it means here everything is there, including stereochemistry, isomerism, conformation of organic molecules, drug molecule synthesis, reduction and oxidation reaction, naming reaction, ring opening reaction, ring making reaction, okay, everything together, organic chemistry. Okay, that is a unit 3. So from the unit 3, so I hope you are very familiar in that organic chemistry. So here the first what we have to discuss here, stereochemistry. Okay, stereochemistry. Right? So here the stereochemistry means, stereochemistry means, what is a stereochemistry? You know that right. So we have to study the molecule in the three-dimensional way. That is a stereochemistry. We have to study the molecules in the three-dimensional way. Whatever we are writing the molecules on the board, that is a 2D structure. Okay, that is a 2D structure. For example, CH2 ClBr. This is not a original structure of the bromochloromethane. Actually, the original structure, you know what is that? That is a tetrahedral structure, right? Br, Cl, H, H. So we are studying the molecules on the three-dimensional structure, three-dimensional view. That is a stereochemistry. Okay. Stereochemistry is a separate chemistry topic for a MSc students. Only the stereochemistry, that is a single paper. Okay, but here not like that. Just we have to touch everywhere. What is a stereochemistry? Similarly, the conformation of organic molecule also everywhere. Just we have to touch that topic. That's it. Okay, right. So stereochemistry means we are studying the molecules through three-dimensional way. That is stereochemistry. So when we look the molecules in the three-dimensional way, the projection of molecule is different. Okay, the people are view the molecules in a different way. For example, Newmann projection, Sawhore projection, Fischer projection. The people are looking the molecule in a different way. Okay, based on that view, they are given the product. They can give the explanation through this way. I can identify this product. Okay, because in the two-dimensional way, we get the product. Instead of that, you get a three-dimensional way product. That is the exact one. Okay, that's why we go for the stereochemistry. Okay, stereochemistry. Here, the first projection is a Fischer projection. Okay, Fischer projection. Fischer projection. So, what is a Fischer projection? Through the Fischer idea, how we can look the molecule in a three-dimensional way. Actually, this is a Fischer projection only. Fischer projection only. So here, flat projection also is there, front and back also is there. The molecule is there in the front and back, uh, uh, front of the board, back side of the board, and left and right. That is the Fischer idea. Simple. Okay, Fischer projection. You write it the first rule. Fischer projection is a flat projection. What is the first rule? What is the first rule? It says project a molecule in a cross manner. Project a molecule in a cross manner. Project a molecule in a cross manner like that. Okay, front and back, right and left. Okay, in a cross manner. And next step, arrange maximum number of carbon on vertical line. Arrange maximum number of carbon on vertical line. Arrange the maximum number of carbon on vertical line. Keep high oxidized carbon groups at top. On the vertical line, which one is top carbon means which one is high oxidized carbon. That I will explain what is a high oxidized carbon. Keep high oxidized carbon at top. I am writing here very shortcut. Don't make a same copy to you. You can write it elaborate. Keep high oxidized carbon at top. For example, CH3, CHO, COOH. Here which one is high oxidized carbon? Carboxylic group is a high oxidized carbon. Right? Carboxylic group, COOH. That is a high oxidized carbon. Therefore, you can keep that high oxidized carbon at the top. Okay, right. The next step, groups on vertical line away from the observer. Groups on vertical line away from observer. This is away from observer. Okay, that means back side of the board. We are looking the molecules. Okay, we are looking the molecules. So here the groups on vertical line away from the observer. Okay, back side of the board, and the groups on horizontal line nearer to the observer. Groups on horizontal line near to the observer. Okay, groups on horizontal line near to the observer. You may write the same example also, fluorobromo, bromochloromethane, bromochloromethane, CH2, ClBr. Okay. So what is a Fischer projection means? This is a Fischer model. Fischer model. Okay, this is a Fischer model. The people have own idea how we have to look the molecule in a three-dimensional way. Some rules they can predict. Based on that rules, they are viewing the molecules. Okay, this is a Fischer idea. Similarly, then what is a Newmann projection? Newmann projection. The Newmann projection is there. The Newmann projection is a ball and a stick model. The Fischer projection is a flat model. Okay, flat model. And the Newmann projection is a ball and a stick model. So here, what is the first rule says? Look at the molecules Look at the molecules through carbon-carbon bond axis. Okay, later I will explain what is a carbon-carbon bond axis. First you write the rules. Okay, look at the molecules through carbon-carbon bond axis. Okay. Next, show the front carbon as a dot and back carbon as a circle. Okay, show the front carbon as a dot, back carbon as a circle. Okay, right. Keep lines on front and back carbon with the 120 degree separation. Okay, with 120. Lines on front and back carbon with 120 degree separation. Okay, with the 120 degree separation. Keeps the lines on front and back carbon with the 120 degree separation. The projection may be staggered or eclipsed conformation. Okay, so you know the staggered conformation, eclipsed conformation, Gauge conformation. Okay, so the projection, it may be staggered and eclipsed conformation. Okay, right. So first look at the molecules through the carbon-carbon bond axis. That is the first rule, right? So look at here. What is a carbon? This is a back carbon. The front carbon as a dot. Keep the lines on front and back carbon with 120 degree separation. So this is the molecule. This is a molecule. This is a Newmann idea. Okay. Ball and a stick model. Ball and a stick model. So if you are looking all the bonds from the front and back carbon means that is a staggered conformation. So now you are looking staggered conformation only. Otherwise, the bond angle from the front and back carbon nearly 60 degree means that is a staggered conformation. Okay. So you know this is a back carbon circle. From here one carbon and here another one bond. Therefore 120 degree separation. So in between the front carbon bonds are there. This is a 60 degree separation. This is a 60 degree. So this conformation is a staggered conformation. Staggered one. Staggered conformation. Similarly, the front, this is the back carbon, this is the front carbon. So you draw the line with 120 degree separation. Similarly, here the back carbon, this is a eclipsed conformation. Eclipsed conformation means eclipsed conformation. That means you are looking only the front carbon bonds. You are looking only the front carbon bonds. The back carbon bonds you are not looking because the back carbon bond, all the molecules hide by the front carbon bonds. That is a eclipsed conformation. Staggered conformation means it gives all the front and back carbon molecules. That is staggered conformation. Eclipsed conformation means only you are looking the front carbon molecules, not back carbon molecule, because the front carbon molecules bond hide for your back carbon bonds. Therefore, you should not view the backside carbon bonds over there. Okay, right. So look at the molecules, two carbon-carbon bond axis. That means, what is this molecule? This is one carbon, right? The circle is another one carbon. Assume everywhere hydrogen is there. That means, what is the molecule? What is this molecule? See, look at here. Suppose this is one carbon, here another one carbon. Methane, ethane. Right? Ethane, that's it. Instead of CH3, CH3. This is a ethane. This is a two-dimensional. In the three-dimensional way, we are based on the Newmann projection. This is a ethane molecule. The front carbon has a dot. Yes, when we look the molecule, the front carbon is a dot. The back carbon has a circle. The bonds are present in the carbon with 120-degree separation. If you are looking all the bonds from front and back carbon means that is a staggered conformation. If you are not looking the backside carbon bonds, only you are looking the front carbon bond means that is a eclipsed conformation. Eclipsed conformation. The Newmann projection is a ball and stick model. So ball and stick model. Okay, ball and stick model. Anything doubt? The Fischer projection is a flat projection. So there, in front of the bond and back side of the bond, right and left. Right and left are plane. Front and back with 180 degree. Okay, front and back. Right. Next is a. May move the next one. Student, are you okay? Either you are sleeping or otherwise you are not listening, otherwise simply you are quiet, otherwise no answer. Okay, right. Next one is a Sawhore projection. What is a Sawhore projection and what is the idea for the Sawhore projection means similar the Newmann projection and Sawhore projection, but here only the stick model, not ball and stick model. So what is the rule for the Sawhore projection? The first rule, look at the molecule in a side way. I will show you later. Look at the molecules in side way, okay, in a cross manner. Look at the molecule in a side way. That means we are looking the molecule in a direct way, that is a Newmann projection. If you are looking the molecule in a side way means that is a Sawhore projection. Okay, Sawhore projection. Show the carbon-carbon bonding in a diagonal, that is this word. Okay, diagonal manner. Not in the straight way. We should not look at the molecule like this. If you are looking the molecule like this means that is a Newmann projection. If you are looking the molecule like this means that is a Sawhore projection in a side way. Okay, because if you are looking the side mirror means you are it is visible all the molecules whatever is there in the front and back carbon. Okay, that is a diagonal way. Okay, right. Show carbon-carbon bonding. Carbon-carbon bonding in a diagonal. Okay, and then next, the same on the diagonal bottom end near to the observer. Bottom end bottom end near to the observer. Yeah, student, I am writing here, but you are not writing. Actually, you only write whatever I am dictating. Just I dictate the notes, I can go. But I don't know, you should not write anything. I am only writing. In a diagonal, bottom end near to the observer. Okay, I will explain what is the bottom end near to the observer and upper end away from the observer. Upper end away from the observer. Okay, upper end away from the observer. The same, keep 3 lines at each. Whatever the rules you are writing here, the same. Keep lines on front and back carbon with 120 degree separation. Okay. With 120 degree separation. This is a Sawhore projection. Sawhore projection is a stick model. Okay, stick model show the carbon bonding on diagonal manner. That means here also the staggered conformation, eclipsed conformations are there. So how we can look at the staggered and eclipsed conformation means, look at here. So what I told, stick model. This is a front carbon, this is a back carbon. That's it. Okay, stick model. Front carbon, diagonal manner we have to look at the molecules. So here the bottom one bond is there. Here also bottom one bond is there. That means this is a staggered eclipsed conformation. If you are looking the diagonal manner, here also carbon is there. Here also one bond is there. Yeah. Here one bond is there. With the front carbon bond only is visible. The back side carbon bond is not visible. Therefore, that is a eclipsed conformation. Okay. And staggered conformation. Look at when I draw the diagram. This is a staggered conformation. That means here downward direction means here upward side, and this is a staggered conformation. This is a eclipsed conformation. So this is a staggered, and this one eclipsed. Eclipsed conformation. So this is stick model. We are looking the molecules through carbon-carbon bond axis, but in that diagonal way. The bonds are front and back carbon with 120 degree separation. Here also staggered and eclipsed conformations are possible. So look at what is a staggered and what is a eclipsed conformation. If you look at here, ball and a stick model. Here only the stick model. Fischer conformation is a flat projection. Okay, cross manner. Right. the Me mean it understood, that is methane, CH3. Okay, CH3. So this is a Newmann projection. Okay, Newmann projection. So when you write it Sawhore projection, similarly here Cl, here Me, here hydrogen, here chloride, Me, hydrogen. Okay, Me and hydrogen. So how we have to convert the one projection, this is a Newmann projection, Sawhore projection, Fischer projection. Okay, Newmann projection, Sawhore projection, Fischer projection. So only they are given this much content only for your stereochemistry topic. That's it. We move the next isomerism. I told you we can touch everywhere the topic. We should not go for in depth of that stereochemistry, in depth of your conformations, R and S conformations. Okay, right. So first, yeah. Any doubt for Newmann projection, Sawhore projection, Fischer projection? Fischer projection is a flat projection. Newmann projection is a ball and a stick model, and Sawhore projection is a stick model.
So Newmann, Sawhore.
Newmann, Sawhore, Fischer projection. Okay, Newmann, Sawhore, Fischer projection. Now we move the isomerism. Yeah, you can write it whatever we are discussing here, because this is organic chemistry. We should not expect what we are discussing on the board. Only the concept you can take it, but they change the molecule in a different molecules they can given. So simply they given for the 1,3 dichlorobutane. Draw the structure of Sawhore projection, Fischer projection, Like that they give the questions. So you know very familiar. Butane means 4 carbons are there. So this also, what is this molecule? Methane, ethane, propane, butane. Yes, I am drawing here for 1, this is first carbon, second carbon, third carbon. This is 2, 3 dichlorobutane. Methane, the front carbon, 1 carbon. So methane, ethane, the big circle, 1 carbon. Propane and another one Ne is there, butane. So second and the third position, chloride is there, therefore 2, 3 dichlorobutane. Okay, dichlorobutane. So they can give different molecules. Okay, don't expect what we are teaching here, the same molecules they ask in your question paper. No, right? You try to draw the all Sawhore projection, Newmann projection. Otherwise, you should not draw in your exam. So how we have to using the stick and the ball, we draw the Sawhore and Newmann projection. You try to practice. And next one is the isomerism. Okay, isomerism. So when I take the class in the first unit, there itself I inform to you isomerism is there in the third unit also. So isomerism means very simple definition, same molecular formula but different structural orientation. Okay, that is isomerism. So in the inorganic isomerism is different. That is there also structural and optical isomerism is there. Okay, structural isomerism, stereoisomerism is there. Here also structural stereoisomerism is there. But their structural isomerism classification is different. That is hydrate isomerism, ligand isomerism, linkage isomerism. That is inorganic isomerism. But in the organic isomerism, structural isomerism is a chain isomerism, position isomerism, functional isomerism. Okay, that is comes under structural isomerism. Okay, right. So isomerism we classify into two. One is the structural isomerism, stereoisomerism. Okay, stereoisomerism. First, structural isomerism, very simple. What is a structural isomerism? First, we take a chain isomerism. Chain isomerism. What is the definition of structural isomerism? The same definition. Molecular formula is same, but different structural orientation, different structural arrangement. That is a structural isomerism. In that, first chain isomerism. Chain isomerism means it varying the chain length. Okay, chain length. For example, to take any example, no issue, because methane, ethane, propane, butane. Okay, methane, ethane, propane. Here one carbon. The chain length will be varying. Here 4 carbon is the chain, but here 3 carbon. 3 carbon is the chain, right? No need to write it like this, but you have to CH3, CH2, CH2, CH3, 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 CH. So what is the formula? C4, H10, that's it. C4H10, right? C4H10. What is the name of the molecule? N-butane. This is isobutane. Okay, isobutane, N-butane. This is an example. Okay, chain isomerism means, what is the definition of chain isomerism? The molecules exhibit the isomerism, it will be varying in the chain length. Okay, when the molecules differ in the chain length means that molecule give the chain isomerism. Okay, chain isomerism. And next is a Position isomerism. Position isomerism. What is a position isomerism? That is also very simple. So when I take a class isomerism, I inform to you. When you listen the isomerism class, you are taught very easy. But when you sit in the exam time, you may get confused. Which one is a position isomerism? Which one is a functional isomerism? Which one is chain isomerism? So little confusion is there when you sit in the exam time. So be careful. What is a position isomerism means? The notified group attached in the carbon, it change the position from one molecule to another molecule means that is a position isomerism. Okay, that is a position isomerism. You take any example, CH3, CH2, CH2, CH2Br, 1 bromo butane. Okay, 1 bromo butane. Now CH3, CH, CH2, CH3, here Br, 2 bromo butane, 2 bromo butane. Right? Here the notified group or else the identified group position will be varying with one molecule with another molecule means that is a position isomerism. Okay, here the Br is there in the first carbon, the same, but Br is there in the second carbon. That is the position isomerism. Okay, position isomerism. So this is not a functional isomerism. Functional isomerism, it is different, varying the functional group. Functional group itself varying. Okay. So for example, one carbon have one molecule have alcoholic functional group, the same molecular formula, but it exhibits an ether functional group. That is a functional isomerism. Okay, functional isomerism. Maybe that also we will discuss. Functional isomerism. Next one. What is a functional isomerism? That's why I told you just now. It will vary in the functional group, but the molecular formula is same, but it exhibits the two different functional group molecules. That is a functional isomerism. So for example, very simple example you can take it, CH3, CH2, OH. What is that? What is the molecule? Yes. Molecular formula is C2H6O. Yes. C2H6O, it exhibits ether group also, alcoholic group also. So this is a functional isomerism. Okay, functional isomerism. The same molecular formula, but it given the ether functional group also and alcoholic functional group also. That's why you already have experience in the 12th standard. They given some problem-oriented questions. When reactor A plus B give the product of aldehyde, when the product of aldehyde reacted with C to produce the chloroethanol, like that they given, or else ether-based chloride substituent. What is the A and B? Like that they ask the question. If you don't know what is alcoholic, ether, carboxylic acid, aldehyde, nitro, acid, amine, imine. So this kind of functional group, if you don't know means you should not answer like that question. Okay, right. That is a functional isomerism. The last one is a metamerism. Metamerism means the both sides of chain length will be varying. This type of isomerism is due to the unequal distribution of carbon atom. It is due to the unequal distribution of carbon on both sides. So for example, maybe CH3, CH2, O, CH2, CH3. Yeah. Here diethyl ether. Okay, diethyl ether. But there methyl propyl ether. Methyl propyl ether. That is a metamerism. That means unequal distribution of carbon on both sides of the functional group. That given the metamerism. Okay, that given the metamerism. Example: diethyl ether, methyl propyl ether. Okay, methyl propyl ether. I have to write the name also, name of the compound also, or else you know. Diethyl ether. Here methyl propyl ether. Okay, methyl propyl ether, diethyl ether. Next, stereoisomerism. What happened, man? Here. See, at the end of the class, don't ask the notes. You are not taking anything in the notes what I am teaching on the board. You should not write anything. Then why you are asking the notes? One day few of the students, I think less than 20%, only they are in the class. Others, they are sleeping, they are doing some work, others they are playing the games or chatting with someone. It's only going. Right? Less than 20% of students only they are following the class. Please stop few minutes. See, listen. What we completed. Listen. In the isomerism topic, structural isomerism we completed. Now we go for the stereoisomerism. Okay, stereoisomerism. Stereoisomerism. So what is a stereoisomerism means? We already discussed. Yeah. So stereoisomerism, molecular formula is same, but it differ in the arrangement of molecules or atom on the space. That is a stereoisomerism. Here we classify two type of isomerism. One is a cis-trans isomerism, another one optical isomerism. Yeah, students, listen. Cis-trans isomerism, another one optical isomerism. What is a cis and trans isomerism? That is very easy. It exhibits mainly the alkene compound. Okay, alkene compound. You know the compound of alkene means C double bond C. Here the same molecules, chloride is present in the same site, mean that is a cis. If the same group with opposite side, chloride, here hydrogen means this is a trans. That is very easy, right? But in the inorganic isomerism, I given the comparison also. In inorganic isomerism, there we discussed the cis-trans isomerism, facial meridional isomerism. Okay, you remember facial isomerism, meridional isomerism in octahedral complexes. Okay, right. Next one is a optical isomerism. Optical isomerism means the molecules rotate the plane polarized light. That compound have optical isomerism. Okay. Yeah, the molecule have ability to rotate the plane polarized light. Okay, plane polarized light. That molecule have optical isomerism. That molecule definitely have optical isomerism. What is a plane polarized light?
PP.
That also we discussed. What is a plane polarized light? Like first unit call. What is a plane polarized light? You know the polarized light means the polarized light in the all directions. It polarizes in the all directions. That is plane polarized light. Plane polarized light means it polarizes only one direction. This is a plane polarized light. If you pass this plane polarized light in the solution, it rotate means this sample have optical isomerism. Okay, optical isomerism. So here again we classify enantiomer and diastereomer. Okay, enantiomers, maybe we differentiate also. Diastereomer. What is a enantiomer and what is a diastereomer? Students listen. What is a enantiomer? What is a diastereomer? That is enantiomer. Yeah, listen. Enantiomer means the molecule give the mirror image. Okay, mirror image. For example, non-superimposed. Okay, this molecule is a enantiomer. This molecule is a diastereomer. Now you tell me what is a enantiomer. From the diagram, what you understood. This is a enantiomer. That is a diastereomer molecule. What is it? This is a enantiomer molecule. This is a diastereomer molecule. The enantiomer means non-superimposable but mirror image. That is a enantiomer. Okay, non-superimposable mirror image. That is enantiomer. Here non-superimposable non-mirror image. Non-superimposable, non-mirror image, that is diastereomer. For example, our right hand and left hand, that is a enantiomer molecule. This is not a non-superimposable. Sorry, this is not a mirror image. Okay. So here, this one is right hand side, this one is left hand side. So non-superimposable. But this is a molecule of mirror image. The right hand side is a mirror image of your left hand side. So therefore this is a enantiomer and both are spring only. But that second spring is not a mirror image of the first spring, but spring. That is a diastereomer. Here both are spring, but the second spring is the mirror image of the first one. So this is a enantiomer. This type of enantiomer, diastereomer exhibit in our fructose, glucose. Okay, there the enantiomer and diastereomer will exhibit. Okay, right? And non-superimposable, superimposable mirror image, that is diastereomer and enantiomer. Similarly, other difference also is there. That means it rotates the it related to the symmetrical operation. That means plane of symmetry, axis of symmetry, alternating axis of symmetry. We do the operation on the molecules. In the enantiomeric molecule, we do the operation. But in the diastereomer molecules, we should not do the operation. That means we should not the plane of symmetry, center of symmetry, axis of symmetry, that kind of operation. We should not do it on the diastereomer molecule, but in the enantiomer molecule, we can do the operation on the molecules. I will explain what is a plane, axis, and alternating axis of symmetry. And this one is optically active. Optically active. This one is optically inactive. Optically inactive. Okay. So there is a difference between enantiomer and diastereomer. Okay, enantiomer and diastereomer. Maybe if we want example. COOH, COOH, OH. Here COOH, yeah, listen. Here, this one and this one is a what is it?
Sir, this one is the major and this one.
This is a mirror image, right? Non-superimposable. That means enantiomer. Right? Enantiomer. This is not a mirror image and non-superimposable. This is a diastereomer. 1 and 2 and 1 and 3 is a diastereomer. 2 and 3 is a enantiomer. Okay, students listen. So here 1 and 2 is a diastereomer, 2 and 3 is the enantiomer. So you look at here, both are mirror image but non-superimposable. That is enantiomer. 1 and 2 is a not mirror image, non-superimposable. Therefore, this is a diastereomer. Okay, diastereomer. What is the time? 10 minutes. 150. Okay, next class.